As I started putting my MongoDB tutorials together, I became really curious about some performance characteristics because I've never really thought about some differences that we see in MongoDB. And what I mean is that all of the APIs in the MongoDB driver that we have as a NuGet package can either take a BSON document, which is the really base form of working with MongoDB, or we can create our own types to use as entities. And I figured, look, we have these two different paths, they gotta have some type of different performance, right? Well, as usual, when putting content together, things didn't go quite as planned. Hi, I'm Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. As I mentioned, I wanted to collect some benchmark data about using MongoDB, but something I found along the way was that the results were less interesting than I thought, but there was something even more interesting that popped up on Twitter and LinkedIn, and that was using async versus synchronous operations when working with the DB. I wanted to test when we're inserting records whether or not we're using a BSON document or a custom type, what the performance would be like. And I might as well test the synchronous versus asynchronous versions while I'm at it. In this video, I'm going to walk through the BenchmarkDotNet setup. We're going to look at all of the code to be able to make the runs work. We're going to look at the individual benchmarks themselves, and then we're going to look at some of the data that came out of that. If you really don't care about any of the code, I'm not going to be offended if you want to jump towards the end of this video and just look at the results, but I think the code's really useful because one of the primary points that I want to get across in this video is that if you're curious about something, you can go measure it. You have all the tools to be able to do it. So with that said, a quick reminder to check that pinned comment for a link to my free newsletter and my courses on DomeTrain, and let's look at the code. And there it is, that's all of our benchmark code. Okay, but seriously, this is just the entry point that we have to be able to run our benchmarks using BenchmarkDotNet. So all that this will do is go scan the assembly for any benchmark classes that we have and run them all. But in this particular case, I just have this one set of benchmarks for inserting. Later on, I'll probably add some more and do some more investigation. But for this, we're going to look at these benchmarks here. I have them flagged as different things up at the top here to either do a short run or medium run job, just depending on the data that I wanted to collect and the time that I was working with. But the other important thing to note is that I'm adding this memory diagnoser attribute up here, and that way we get some memory information when we're benchmarking. The two really important things aside from BenchmarkDotNet that we're using are test containers, and we are using the MongoDB C# driver. The reason that I'm using test containers is, yes, of course we're going to be working with a real running database, but I wanted to try and normalize this as much as possible. I totally get that if I'm running a whole other service on my computer, it's not going to be perfect, but I figured if I had to go out to the internet to a hosted MongoDB database, this is going to be perhaps more realistic or representative, but the other thing is that there's other things that I'm not in control of, so I just wanted to be able to do an apples to apples comparison here. So if you haven't seen how to use test containers and you're curious about that, you can check out this video that I just put out on how to leverage that, especially with MongoDB. Now I do have a bunch of fields declared up here that we can initialize in our global setup, and that's just so that we're not paying any type of performance penalty up front for doing that inside of the benchmark methods. If I scroll down to the global setup, you can see that we're going to run this code here to create the container using test containers, and then we start it right here on line 28. This part here is creating a Mongo client so that we can connect to our database. And then lines 32 through 36 are going to get us our collections that we're interested in working with. And you can already see that I'm introducing a bunch of different variations here. So we have the BSON document. This is sort of that base case that I was interested in. And then I figured, look, I want to have some really simple documents to work with, but we have different types that we can use. And what I mean by different types is sort of like a record. We could use a struct, a class, so we're dealing with reference or value types. I was really curious to see if we'd notice any patterns across using these in different ways. So I do have all the variations here. So we have a BSON document. We do have a record that is a struct. We have a record that's a class, and then we just have a normal struct and class as well. It's almost no extra work to go add this in, so I might as well, and then we can see if there's going to be anything interesting that comes up. If I quickly jump to the end of this file so we can look at the implementations of these, so you can see that the definitions of these are all very simple. They just have a single name property to work with. So nothing fancy, nothing hierarchical, just a single property that we can set. Now to scroll through some of the benchmark code, it's going to be a very similar pattern, so I'm not going to spend a lot of time going in depth on each individual one, because the whole point that I'm getting across here is that we're going to be looking at different types. They look very similar, like they have the same shape of data, but they are either reference types or value types, records, structs, or classes. Now, when I put this together, the other thing that I mentioned at the beginning of this video is I said, hey, look, there's this other information that pops popped up on LinkedIn and Twitter, and that was talking about the fact that async operations seem like they're even slower than normal synchronous operations for database operations. And I thought that was interesting because I've almost defaulted to everything just being async await. And I had this clever idea that one of the things that was potentially slowing it down, if that was in fact true, is that it was the task, right? And we have this value task that we can use as well. And I figured, you know what? It's gotta be that. This was my hunch. So I tossed that thing into the mix as well. So we have variations that are async with a task, variations that are asynchronous with a value task, and then I also have the synchronous versions as well. So this is pretty straightforward. You can see that as I scroll through here, we go from the BSON docs into the record struct DTOs that I have here. Very similar, right? So insert one async, then this one has the value task, and then this is the non-async version, so on and so forth. So just to quickly scroll through, you can see that I'm doing all of the types that I had declared at the bottom. And to me, this was just a really simple way to have coverage across all of these different scenarios. And I didn't have any assumptions going into this, right? I was hopeful that async would be faster because I'm used to using async everywhere now. But things on Twitter and LinkedIn made me think otherwise, so I was very curious. I was hypothesizing the value task might be faster. Still no idea, right? A total hunch. And then if I had to think about the types that we have to work with, whether it's a struct or a class, my gut feel was telling me that using a struct would be faster than a class to do the serialization. And then I figured if we have a record version of these as well, that the record was potentially adding a bit more overhead because there is a little bit more going on behind the scenes. And that's just because at compile time, we get these other things added onto them. So I figured maybe the serialization ends up doing a little bit of extra work because it has more things to look at. I had no idea though. This is just me speculating. So now I'm going to make you sit and watch all of the benchmarks run while I go get a drink, and I'm going to come back in about 25 minutes. So I'll see you in a little bit. Okay, I'm kidding obviously because I've already written a blog post about this and have all of the results as well. So fortunately for all of us, we don't have to go through that. I do have this written up. As I said, I'll put a link in the description if you want to read through this, but this video is covering the same topics as well. This just has a little bit more detail as I go to write it out. So if I jump over to the benchmarks, which are at the end of this article, this is what they look like. So there's a lot going on the screen here, but the columns that I'm interested in personally are the mean column right here, right? So that's the first column of numbers, and then the allocated column, and that's going to be the memory that's allocated. So we can start by looking at the allocated column first, just because there's a few patterns that stand out, make it pretty easy to talk through, and then we can kind of park that. So if we look at the allocated column, there's numbers that are roughly around 22.62 kilobytes, and the other numbers that we see coming up are right around 17.78. There's 17.71, so right in that range as well. They're not exactly the same in all of the scenarios, but very similar. And the thing that I wanted to call out is the ones that are about 5 kilobytes bigger. Across the board, they are all async. So to me, that's kind of interesting, right? That's definitely a pattern that shows up. It does not matter if it's async with a normal task or async with a value task. In any case, they are going to be this number that's around 22.62 kilobytes, so no difference there at all. Okay, now bringing our attention over to the mean column. Again, the things that we're interested in comparing are async versus synchronous, as well as the different types that we have to work with. And in particular, I'm really interested in seeing if there's a struct versus class, like reference type kind of difference going on here. So let's have a scan through the numbers and see what's up. I want to call out, first of all, that this one right kind of in the middle of everything, that's insert one async record class, this does have a pretty large error proportional to everything else. Kind of interesting. It might be worth rerunning this benchmark to see if this is going to maybe be a bit of an outlier. Not totally sure, but I'm kind of rolling with this one for now. It does seem like it's pretty far on the outside of the runtime here, but maybe not so far that it's not realistic. So the first comparison that I want to do is looking at async with a normal task versus a value task for performance. And if we start scanning top to bottom, we can see that for the first two, we have the value task taking a little bit longer than the normal task. That's one example disproving my theory about a value task being faster in this situation. If we go down a little bit lower, we can see yet another example, like the 676 here versus 605 microseconds. The value task was slower once again, going down even further. This one is kind of comparing to the outlier, so might be garbage data, but this is in my favor. But again, it might be because this standard error is kind of throwing things off. So I don't know if I trust this one. This one's kind of a moot point, I would say. A little bit lower, we can see value task 605 compared to 642. Okay, this one is in my favor. And going a little bit lower, we can see value task yet again a little bit slower. In my opinion, I don't really see a big trend here. It kind of looks like it's in favor of just using a task over a value task. There's a couple of differences that we saw as we scan through this, but honestly, it looks like if you had to go async, probably just using a normal task in this case is showing us that it is a little bit better overall across these scenarios. Okay, now that we want to look at the types, because I think that's going to be something interesting. That was my original mission with going in this direction for getting benchmarks here. I think one of the ways that we can look at this is start looking at the groupings of the different things together, right? So we know that async is going to be slower. So maybe to start, let's just start with the synchronous versions of them. And if we're not really set on that, we can jump back to looking at async to see if there's any variations coming up. So starting from the top, bson document being inserted. This is at 514 microseconds. Bson document is kind of that base type that we have to work with in MongoDB. It kind of feels like it's just a dictionary, right? You can keep adding things. It's extensible that way. It's not going to be a very strict type in terms of defining your own data transfer object or entity. So 514 microseconds. If we go down to insert one for the record struct, that's 575. So it's 600 microseconds slower. Interesting. I thought that it being a struct would automatically kind of catapult it ahead, but not the case here. If we go a little bit further, insert one record class. Interestingly enough, this is faster than the bson document. Again, I wouldn't have expected this because not only is it not a value type, it's a record. In my opinion, this would have been, one of the worst case scenarios, because I mentioned a little bit earlier, I hypothesized that a record might have added a little bit of extra bloat in terms of the extra functionality that they add. I know that's done at compile time, but I figured when it's serialized, it might have to go look at extra data. So I was completely wrong about that. If we go a little bit lower, insert one struct is 521. So that is pretty good. That's comparable. But if you look at the data that we have here, 514, 511, 521, these are extremely close, right? The one that was a bit of an outlier was the record struct here. Yeah, I don't really know if I have an explanation for that compared to the others. To me, they all seem extremely similar, right? I mean, the data says here, don't use a record struct, but the other three flavors that we have, they're super similar. So in this particular case, I would say if you're like, hey, well, should I use a bson document or should I use like a record, just a standard record that is a class? I would say this is going to depend on your needs, right? Performance-wise, they look almost identical, right? In terms of usability and things like that, I flip-flop between them. If I'm kind of building out what I want my data to look like, I might stick with the bson document. If I want to offer a lot more structure, if I want to make sure that I can migrate between like my schemas and stuff, I like using more concrete types that are defined. You kind of get flexibility versus strong typing, right? And this is going to be a trade-off. Like, I mean, in other languages, you just have this in general coming up as a trade-off between languages. So I think it's kind of up to you to see what you want, but performance-wise, it doesn't look like there's a big difference here. Okay, so performance-wise, when I set out to go get these benchmarks, I was completely disappointed and didn't have anything stand out in terms of the different types. I was really expecting to see, once I dug into it, that something like a struct would be faster. Why? I mean, if you're in the comments on this, you might be going, well, that's stupid. Here's why it's not. Like, I don't know. It's just a hunch that I had that it would be faster. And I figured bson document is this really generic base class that they have to work with. I figured that might be the slowest one to work with. So kind of interesting that I was just completely wrong on this, but that's exactly why we set out to go measure these things and prove it to ourselves. The other thing that was really interesting about this data is that across the board, async was slower. Wait a second, we didn't even talk about that. We talked about the memory. All right, let's do this quick. So the data that we have on screen is showing in sets of 3, 2 async and 1 synchronous version of each document type. And that's because async is going to be with task and value task. So if we have a quick scroll through the mean column, and we'll start with bson document, we can see that the synchronous version is significantly faster than both async versions. Jumping down to the next set of 3, record struck at 575 compared to the rest. I mean, even the fastest async one is about 30 microseconds slower, right? So again, beats out the async versions. Going down to the next 3, 511 is significantly faster than the 2 async ones above it. And yes, this one with 722, we keep saying this one's an outlier, but even so, I mean, how much of an outlier is it going to be? I mean, if we look at the other examples so far, it seems like async is always a little bit slower. And I mean, we see that already with the 583 compared to 511. So even with that outlier, the one async that we have to compare to is in fact slower. Going down to the next set of 3, 521 compared to 605 and 642. 521 is significantly faster than both of those. And then when we get down to the bottom, when we start looking at the insert one for class, we see 598 compared to the other 2. This one is interesting. This is the only example where we see async in fact being faster. So that's interesting. I don't have a good explanation for it. It's the only outlier. 570 compared to 598, 592. I mean, all kind of in a similar-ish range, although insert one async with the class is definitely faster than the other 2 that we see listed right at the bottom. But if we take 570s so insert one async with the class, 570, that's the fastest one that we have for classes in general, right? If we go compare that to the other ones that were fastest in their synchronous versions, 570 compared to 521, not as fast. 570 compared to 511 up here, not going to beat that. And then 570 compared to 575. I mean, it's even faster than inserting one with the record struct, right? So, and then 514 at the very top here for BSON document. I mean, overall, the async version for class, even though it's faster than the synchronous version for class by a little bit, it's still not really beating out the other examples we see. So my personal takeaway from this is that inserting one with a BSON document synchronously works pretty good. It's probably close to being the fastest that we have on the list, except for when we're dealing with our record type, inserting one also synchronous. These 2 variations were almost the exact same in terms of runtime, and they seem to be faster than almost all the rest on the list. With that said, though, these are slightly contrived, right? Like, I don't know how often in your application you're going to be inserting a single document versus doing bulk inserts or bulk writes of other types. So what I want to urge you to do is, if you're looking at this data going, well, that means I have to go change my whole app to stop using async and change to using record types instead. Like, that's not what I'm suggesting at all here. I don't want you to have that as the takeaway from this video. The takeaway that I want you to have is that if you're curious about what these types of things look like at runtime in terms of memory and their performance, I would say benchmark them, right? Come up with the scenarios that represent what's happening in your application and benchmark them. Profile your application, figure out where you have hot paths and try to see, cool, if I have a hot path that looks like this, can I write a benchmark for it to exercise that? And then can I come up with a variation and compare them? Like, that's what I want you to get as a takeaway from this. So I'm doing it because I had a hypothesis, but in a real application, this is not necessarily going to be what you're doing, right? I don't know what your application looks like. However, you got to see all of the tools that you could use to go write benchmarks for yourself. And if you think benchmarks are cool and you want to see more of them, maybe not necessarily with MongoDB, you can check them out for collection initializers in this video when it's ready. Thanks, and I'll see you next time.